guys. So our topic is brain signal to hand movement detection. Firstly, let's focus on pre-processing the data. In this step, first we will first separate data X and label Y from raw data set. Then split the data into train and test in ratio of 80 and 20. For training in neural networks, we will normalize train and test data using minimum and maximum scalar normalization. This normalization is done so that neural networks can converge faster. Feature extraction. In this step, for training on SVM and logistic regression, we will extract statistical features as discussed above. So, statistical feature extraction. Extract statistical feature like mean, standard deviation, curve, skewness, band power, etc. and train it classification algorithm. SVM, logistic regression. So when a new EEG signal comes, we will first extract statistical features and then send it to classification algorithm and predict the output.
Hey guys, so basically what I have to do in this project was to apply the basic machine learning models on the already pre-processed data and increase the accuracy of the models as much as we can. So we will see, I have applied two models, logistic regression and the another is neural networks. In neural networks, I have used recurrent neural networks. So logistic regression is another technique for classification which uses sigmoid function and two-class classification. Logistic regression, we can take logistic regression as a benchmark model because it has a simple algorithm simple algorithm with nonlinear sigmoid function. They provide good baseline accuracy. The second which I have taken is neural networks. So in neural networks, I have used recurrent neural networks. The basic idea behind recurrent neural network is to make use of sequential information. The traditional neural networks, the data was assumed to be independent, but as we know that data points in the time series are dependent, feature values depend on previous values. Okay, so our RNN has loops in them that allow feature values depend on.
Hello guys, I worked on SVM and LSTM for this project. I took SVM as the base model and LSTM as the main model and compared both of them to check the accuracy. SVM stands for Support Vector Machine Model. What it does is basically create a line or a separator upon the previous data set and compares the new one to them. So basically, if you have a plane on XY, it will make a line or a curved line to separate the data set from separate two different kind of data from one another and compare the next test data with it. This separation is basically called the outliners. So it does not exist only the x and y plane, but it may also exist on the z plane. So it's kind of a hyperline. What LSTM is a kind of a neural network. So normal neural network have a problem of not utilizing what they have learned previously. So the LSTM overcomes this drawback, and LSTM actually stands for long short-term memory. So as its name suggests, it has a good memory of the previous events, and it actually utilizes the previous events to learn more about the current events or apply the previously learned knowledge on the current events for faster algorithm and better deduction of the outcome.